Alright, finally on to the unit test. Let's get started. Which of the following are opposite of cosine theta? Cosine theta here is positive. Cosine theta is here. Cosine pi minus theta. So pi minus theta. Yeah, first answer looks good. 2 pi minus theta. Nope. It's still here. It's not B. Pi over 2 minus theta. Pi over 2 minus theta. That looks like it's here. I don't think it is, but I'll check back. Pi plus theta on pi. Oops. Pi plus theta. That looks like it's here too. Last one looks good. Nice. Okay. Since 5.2, it's 1.5 cosine 2 pi 365 t plus 4.3. 5.2 minus 4.3 is 0.9. 0.9 divided by 1.5 is 0.6. 0.6 equals cosine of 2 pi 365 t. So the first solution, this is in radians, and yeah, my calculator is already in radians, so I'm fine. So 0.6 equals, I'll just go straight to inverting 0.6, changing it to this, and then 65, how about do minus 2 pi n here, and 2 pi inverse cosine 0.6, and minus 365, and this is after, so this is 2 pi n turns to 365 n after. So inverse cosine of 0.6 times 365 divided by 2 pi, you get 54. It's asking for the second time, so I'll do the second equation. So inverse cosine, wait, no, not up to that yet. 0.6 equals cosine of 2 pi minus 2 pi 365 t, and then take the inverse cosine of both sides. 0.6 is 2 pi minus 2 pi of 365 t. I'm going to disregard the 2 pi n because I don't think it's necessary. We already found it in the other identity, so I'll go on. And then after this, minus 2 pi equals negative 2 pi over 365 t. 365 over negative 2 pi. Inverse cosine 0.6 minus 2 pi equals t. This becomes 365. Yeah, okay, so inverse cosine of 0.6 times 365 divided by negative 2 pi plus 365 is 311. 311. Nice. Alright. Find cosine pi of 12 exactly using an angle addition or subtraction formula. Okay, so pi over 3 equals 4 pi over 12. Pi over 4 is equal to 3 pi over 12. And pi over 6 is 2 pi over 12. And what can get us to pi over 12? looks like pi divided by pi over 3 minus pi over 4 can get us there. So cosine of this is the identity cosine A plus negative B equals cos A cos B. Now I'm really got clearer. Cosine A cos B. You don't need to negate it because it's an identity. And then minus sine A minus sine A sine negative B, or you just negate this symbol and just put sine B. So cosine of pi over 3 cosine of pi over 4 plus sine pi over 3 minus plus sine pi over 4. I think that's the identity. I might be wrong. Okay, so cosine pi over 3 is 1/2 times cosine pi over 4 is root 2 over 2 plus sine pi over 3 is root 3 over 2. This is supposed to be multiplication symbol. Times sine pi over 4. It's root 2 over 2. So this is root 2 times 4 plus root 6 times 4. So it's root 2 plus root 6 over 4. Root 2 plus root 6 over 4. That one looks, yeah. Nice. Okay. This looks like, this is just a 30-69 triangle. So this 30 degrees is 60. This is the side opposite to 30 is half of the hypotenuse. So this is 2. It's 2 root 3. Tangent of pi over 6. Opposite over adjacent. 2 over 2 root 3. This equals to 1 root 3. That's root 3 over 3. Root 3 over 3. Nice. Okay. Cosine 315. Alright, let's do 315 minus 180. That is 135, right? Oh, I have a calculator. What am I doing? 195. I can't do math. 195. And then do it again. 15 times 180 pi 15 over 180. That's pi over 12. Wait, what does 45 go evenly in that? Yeah, 45 goes evenly in that. So I'll just find, so I'll just use 45. 45. It's root 2 over 2. This one, and 315 divided by 45 equals 7. So it goes, so 7 pi over 4. This is pi over 4. So 7 pi over 4. 3 pi over, I'll get rid of a pi by going here. 3 pi over 4. That's the same thing as like, so this right here is pi, going here, there is pi. There's pi over 4 left. And it should be like this. So cosine is still root 2 over 2. Sine is negative root 2 over 2. Cosine root 2 over 2. Root 2 over 2. Sine is negative root 2 over 2. Negative root 2 over 2. Nice. Okay. Wait, it's in radians, so that's, yeah, my calculator is already in radians. Okay, so we'll just solve. Subtract 1 from both sides. You get 6 sine 20x equals 0. Divide 6 on both sides. It's the same thing. Set up the identities. Sine 20x plus 2 pi n equals 0. Sine pi minus 20x plus 2 pi n equals 0. And I'll solve the first one first. Inverse sine of 0. Inverse sine of 0, which is just 0, equals 20x plus 2 pi n. Inverse sine of 0 minus 2 pi n equals 20x. 1 over 20. Inverse sine of 0. Pi over 10, I think. Is it? Divide by 20. Yeah, that's pi over 10. That's the first solution. The second solution, inverse sine of 0, pi minus 20x plus 2 pi n. Subtract 2 pi n on both sides. Equals pi minus 20x. Subtract pi on both sides. Equals negative 20x. Divide negative 20 on both sides. Plus pi over 20 plus pi over 10 n. This can also be plus because n is an integer, and this is the second solution. So I'll just enter all this in the calculator. So 1 over 20 inverse sine of 0 plus, okay, that's it. Okay, that's 0. That's just 0. Yeah, so this on its own is it's a solution. So yeah, this is one, and negative 1 over 20 inverse sine of 0 plus pi over 20. Alright, so wait, so it's basically it's just this over here. Okay, so pi over 20 plus is that 2. Pi over 20 plus 10 n. Yeah. Nice. What's the principal value of that? Okay, so for cosine, it's limited to the first and second quadrants, I believe. Why can't this draw? Okay. Okay, it's limited to the first and second quadrants over here. So 1.504 0.04 divided by pi, that's about, it's a little over than a pi. So it's like, goes like here-ish. Wait, no. Wait. Yeah, that's over pi. That's over pi. So it's not in that range. And anything above that is not. Okay, so it should be just this. Nice. Okay. So this looks like law of cosines. So it goes like c squared is a squared plus b squared minus 2ab cosine theta. So c squared is unknown. It equals 736 squared. Oh, I need to set my calculator back to degree mode for this. 76 plus 915 squared minus 2, 736, 915 cosine. Oh, yeah, cosine theta is given, so cosine 3 degrees. Taking the whole square root of this would just give me the answer, so I'll just enter all of this in the calculator. Okay, so square root, and I am in degree mode. Okay, square root of 736 squared plus 915 squared minus 2 times 736 times 915 cosine 3 degrees. That is 184. Should be 184. Nice. Last question. Okay, what does the least positive solution for that represent? So, the horizontal distance of the end of a blow from their body, that represents that. That's given. And we need to find out the seconds. So, this says distance. We can eliminate that, and this also says distance, because distance is already given. So, and it says the least positive solution, so it's not all the numbers. It's this has to be that, because it's the least positive. All right, that's the unit test. Great. That's Unit 2, Trigonometry done. We have 1, 2, 3, 4.